Good day everybody, this is a beautiful question and the author has already presented the solution for this question. Now what I'm going to be doing is I'm going to give an alternate method to solve this question. Now this question involves a lot of geometry, but I'm not going to be using geometry. I'm going to be using trigonometry, and thereby the solution for this question would be much simpler. So having mentioned that, we got a semicircle, and then the semicircle is actually present inside a rectangle. So I need to get the rectangle now. So okay, so this is A, B, C and D. Now I need to draw a circle here, so let me find a device to get the circle drawn here. I don't want to use a freehand, so I need to look for a device to get the circle now. Okay, so I was able to get the small circle over here. Now let me specify the following information. The small circle has a point of contact with the line AB at E and a point of contact with line AD at F. So this point is E and this point is F. So that would mean the circle has two tangents at E and at F. Now why am I specifying this? Just to bring an air of clarity to the figure. So there is just one point of contact at E and another point of contact at F. Now also, this is another information I'm giving. Also, the small circle has a point of contact with the semicircle at, now you can have this say at G, right? So there is a point of contact here. Now this is the center. This is the center for the semicircle. So I'm just taking it as O. Right? Now what I'm going to do is, this is for giving air of clarity to the figure. Now as I mentioned to you, there is a point of contact that the small circle is making with the semicircle. So I've taken the point as G. Now there is a theorem. If a line were to be drawn through the point of contact of the circles, then that line will pass through the centers of the circles. So that's a very important concept. So the meaning is, if I were to draw a line like this, then that line would connect the circles. That is the meaning. Now I need to actually make sure that the line is hitting the point A and it is drawn through the center and then hitting this point of contact and then hitting the center at O. So that is important. Now of course, if you were to extend this particular line, that line would actually hit the point A. Why do I say that it will hit the point A? Because the point A is actually the point, an external point through which two tangents are being drawn. So since we have two tangents drawn, and if I were to draw a line from the center to the tangent, that would be 90 degree. Similarly, if I were to draw a tangent, or I should say draw a line from the center to this tangent, that will be 90 degree. So in all, we got a 90, 90, 90, and this corner is also 90 degree because this is part of a rectangle. So any line that we are hitting, which is connecting the centers, will also connect or will also hit the point A. So having mentioned that, let me connect and okay, we have connected, and that's a good line given the free hand in which I'm drawing. Okay, that is fine. Now there are a few things we need to do. Now it is given in the question that the area of the semicircle is 2 pi square units, right? So foremost, what I'm going to do is I have to formulate a few information. So I'm going to state here, let capital R be the radius of semicircle. Let small r be the radius of small circle, and since area of semicircle is equal to 2 times pi, this means pi times r squared, but this is the area of the semicircle, so you have to divide by 2 and equate it to 2 pi. So this would mean pi times r squared is equal to 4 times pi. Pi can be cancelled, so r squared is equal to 4, therefore r is equal to 2 units. Now just have this in one corner. We've got r is equal to 2 units. Now we got to go back to the figure and apply trigonometry. Let's do that. Now if you see the figure, the semicircle is clearly present inside the rectangle. There is a point of tangency here, there's a point of tangency here, there's a point of tangency here, and we know it's a rectangle. So this is 90, this is 90. Now what I wish to do is I'm going to drop a perpendicular from O to the point of tangency, right? Now whenever by theorem, if I were to draw a line from the center to the point of tangency, that would be making an angle of 90 degrees. So this is actually a 90 degree angle. Okay, fair enough. Now what I wish to do is I would like to draw a line from the center of the small circle to this perpendicular, right? Now if I were to draw that, that's a perpendicular line. So from the center I'm drawing a line, drawing a perpendicular to this line. So if I were to take this as OP, from say C1, I'm taking this point as C1, from C1 draw a perpendicular to OP. So that's what I'm going to do. So if I were to draw that, it's a perpendicular line, so that means it would be hitting OP at an angle of 90 degree. So this is going to be 90 degree. Okay, fair enough. Now, since I've said I'm going to utilize some trigonometry, I know this distance. Say, I've taken the point of contact over here. If you were to see here, the point of contact of the two circles to be G. So if this point is G, we know that OG is equal to capital R. Of course, we have found out the value of capital R, and GC1, and GC1 is equal to small r. That's also a radius there, right? That's a small radius. Now, therefore, OC1 is going to be capital R plus small r, right? That will be the total length. Now, if I were to take this as, say, theta, what do you think theta is going to be? Now, please remember, I have clearly mentioned to you that the line drawn through the point of contact is going to be hitting the center. So that would mean this is going to be an angle bisector. We already know that this is a rectangle. So this is 90. So this entire angle is going to be 90. But this line which is drawn is an angle bisector. So that would mean this angle is going to be 45 degrees, right? Now, if I were to take this entire OC1, I've taken it as R, capital R positive small r. Is it okay that I can take a value for cos 45? What is cos 45, do you think? Cos 45 is going to be equal to this side. Say, let me take this as some k. Cos 45 is going to be the adjacent side, which is OK, divided by this entire hypotenuse side, that is OC1. Is it okay? But what is OK? OP, this OP is equal to capital R. OP is equal to capital R. But what is KP? Can you tell me what is KP? Now, KP is the line drawn from the center of the small circle, right? Or I should say, if you were to equate KP, KP is in line with C1E. Now, if you were to draw C1E over here, let me draw that C1E. Now, what is C1E? C1E is nothing but the radius of the small circle. Now, C1E and KP are actually in line. They form the sides of a rectangle. So, I've taken C1E to be the radius of the small circle. So, that would mean KP is equal to R, right? So, KP is equal to R. So, I need to get OK. And to get OK, what should I do? I need to take from capital R, because OP is going to be capital R. And from OP, from capital R, I'm going to take away this KP, which is nothing but lowercase r, small r, which is in line with the radius of the small circle, divided by OC1. What is OC1? OG is capital R and GC1 is small r. So OC1 is nothing but capital R plus R. So we have a system here. So what is the system we got now? Let me write that down here. Cos 45, I'm utilizing this part of the page. Cos 45 is nothing but 1 over root 2 is equal to capital R negative R divided by capital R positive R. Now we know that capital R is equal to what? 2 units. So this would mean I got 1 over root 2 is equal to 2 negative R divided by 2 positive R. So you cross multiply, you get 2 positive R is equal to root of 2 times 2 negative R. We need to get R. So 2 positive R is equal to 2 times root of 2 negative R times root of 2. So bring this to this side, push that to the other side. I'm utilizing this space. So R positive R times root of 2 is equal to 2 times root of 2 minus 2. You can take 2 out. So it's going to be root of 2 minus 1. Over here you take R out. It's going to be 1 positive root of 2. So therefore what is the value of R? So I'm writing it down here. R is equal to 2 times root of 2 minus 1 divided by 1 positive root of 2. Now I can rationalize this, right? So let me rationalize this in this new page and show that to you. So what I've got here, I've got R is equal to 2 times the root of 2 minus 1 divided by 1 positive root 2. I'm going to multiply this by 1 negative root 2 and actually instead of doing it like this, what I'm going to do, I would take r to be as 2 times root of 2 minus 1 divided by root of 2 plus 1. So my product multiple will be root 2 minus 1 divided by root 2 minus 1. It will be simpler in this case. So it's going to be 2 times of, this is root of 2 minus 1 raised to the power of 2 divided by, this is root of 2 squared minus 1, which is equal to 2 times, you square this, you get 2 negative 2 times the root of 2 positive 1 divided by root 2 squared is going to be 2 minus 1, which is going to be 2 times of 2 added with 1 is 3 negative 2 times root of 2 divided by 1. Now root 2 is approximately 1.414. So you multiply it by 2. What do you get? You get 4 times 2 is 8, 2 point. You get 2.828, and you take away from 3, you take away 2.828. So it's going to be 2, 9 and 7, 9, 1 and 0.172, and you multiply it by 2, you get 2 to the 4, 7 to the 14, 1, 2 ones are 2 and 3. So approximately you are getting this value. Okay, this is the value. What is the approximate value? Therefore r is approximately 0.344. This is an approximate value, but we need to find the area of the small circle. So therefore pi r squared is equal to pi times 0.344 raised to the power of 2. So this would approximately be 0.37 square units, right? Whatever units they give, that would be the solution. So this would be the area of the small yellow circle. Thank you everybody. We have utilized trigonometry. Of course, in spite of using trigonometry, we have to take in a few concepts in geometry also. Thank you everybody. Like, share and subscribe the video. Until we meet again.